Dear students, now we are going to discuss the basics of KarnaughMap in detail. KarnaughMap, simply called as K-map. It is a systematic approach for simplifying the complex Boolean expression. So it is mainly used to simplify the complex Boolean functions. It is also known as Veitch diagram because this map method was first proposed by Veitch and then modified by Karnaugh. This K-map contains square boxes called cells. For n variables, there are 2 power n cells. Let's discuss the K-map formation. For one variable, that is n is equal to 1, there are only 2 cells. 2 power 1 is equal to what? 2 cells. It can be represented like this. Here, a bar a. A bar is equal to 0. Bar, that means complement. That is equal to 0. And here a is equal to 1. The same can be represented like this. Here the 0 denotes the value of the cell. 0, here it is 0. Its value is 1, so it is 1. In terms of sum of products or minterms, we can represent the cell as small m naught. Okay, here it is small m o. Okay, this cell is denoted as m1. In case of product of sum or max term, we can represent the cell as capital M O, capital M1. So here it is nothing but 0. Okay. So in max terms, we have to represent A is equal to 0, A bar is equal to 1. So next one is 2 variable K-map. Here n is equal to 2. Then there are 4 cells. 2 power 2 is equal to 4 cells. Here A represents the row, B represents the column. So A bar is equal to 0, A is equal to 1. So here this column is 0, 0. Correct? 0, 0. So its value is 0. Here it is 0, 1. Its value is 1. 1, 0. 1, 0 represents what? 2. 1, 1 means 3. Okay, so these values are the exact values of the combination of these two variables. Okay, the 0 can be represented as A bar B bar. Here one is A bar B. Here it is A B bar. The fourth one is A B. So in terms of SOP or min terms, we can represent as M0, M1, M2, M3. In terms of max terms, we can represent the same as capital M0, M1, M2, M3. But here it is A is equal to 0, A bar is equal to 1. Likewise, B is equal to 0, B bar is equal to 1. Here we have to use the term plus because it is product of sum. Next one is 3 variable K-map. So here n is equal to 3. Therefore, there are 8 cells. That is 2 power 3 is equal to what? 8 cells. Here we have to consider A as a row variable, BC as the column variables. The combination of BC as the column variables. Here, whenever we are grouping 2 bits together, we have to consider gray code sequence. What is meant by gray code sequence? It is a sequence of bits in which one bit changes from its previous and next bit. For example, the first value here it is 0, 0. The next one is what? 0, 1. So the next one is actually it is 1, 0 because 0, 1, 2, 3. Okay. So here 0, 0, 0, 1. The actual bit is 1, 0. If I am going to put 1, 0 means 2 bits are changed. Correct? If I am going to put 1, 0 for this next column, it may be 2-bit variation. But here we are going to consider gray code sequence where only one bit is changed from its previous and next so that it becomes 1, 1. So here it is 0, 0. The next one is 0, 1. So there is only one bit changed, right? So in the next one it is 1, 1. And then 1, 0. So you can see there is only one bit changed from its previous and next bits. Okay. So here we can represent A bar, that is equal to 0, A is equal to 1. Likewise B bar, C bar, B bar, C, B, C, B, C bar. So here its value is 0, 0, 0 is 1, 0, 0, 1 is 1, 0, 1, 1 is 3, 0, 1, 0 is 2. Correct? Likewise here 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 1, that is 7, 1, 1, 0 is 6. So we can represent this schema with its minterm M0, M1, M3, M2, M4, M5, M7 and M6. Similarly, we can draw the K-map for 4 variables. So n is equal to 4 means 2 power 4, that is equal to 16 cells. So 16 cells, here it is. A, B represent the row variables, C, D represent the column variables. Okay. So here A bar, B bar, A bar, B, A, B, A, B bar. So here also the same thing, gray code sequence, there is only one bit is changed. Okay. So only one bit is changed from its previous and next bits. Okay. So these all are the values. So this representation is very important. Based on that, we can solve Boolean expression problems. After placing the values, the next step is to group the adjacent ones. We can group the adjacent ones as pairs, quads or octets. So here pair means group of 2 ones. Quads means group of 4 ones. Octet means group of 8 ones. So let's see each one with its rules. Let's start with grouping of pairs. Grouping of pairs means if there are 2 ones. Okay, there are 2 ones, then we can group these 2 ones vertically. So there is one more case where 2 ones are like this. That is, we can group 2 adjacent ones in horizontal order or vertical order. So we should not group the ones like this. Okay, so one is there. Diagonally we should not do. So this is illegal one. So if I am going to group these 2 like this is the illegal one. So diagonal grouping is not permitted in K-map. So we can group only in vertical or horizontal order. Okay. So that's very important. So if I am going to group the ones like this. Okay. So I have grouped it. Then the value of this group is the common term. What is the common term in this row? A bar. So here we can take A bar. What is the common term for these 2 columns? Here it is B, here it is B, here it is C, here it is C bar. So C plus C bar is nothing but 1. Correct? So we can simply ignore the different bits. We can take only the common bits. So for these 2 ones, the common bits are A bar and here it is B. So the answer for these 2 ones. Okay, these 2 ones can be represented as A bar B as a single expression. So likewise for this grouping, how do you represent this? So for this group, so which one is the common? Here it is A bar, here it is A. So A plus A bar is a 1 value. So we can ignore it. So common value is nothing but B bar C. Is that okay? So if I am having the values like this, finally I can write the answer as A bar B plus BC. Okay, then I can further simplify this. B is a common, then I can write A bar plus C. Okay, so this is how we can simplify the Boolean expressions. So the next one. So here group of 4s. So here I can have one like this. There are 4 ones, the remainings are 0. Consider the remainings are 0. Then I can group the ones like this. Okay, so for this grouping, this is for group of 4s. Okay, so for this grouping, what is the value of Boolean expression? So here the common term is a bar. What's that? The common term is a bar. Okay, so likewise we can group these things. So next, and one more thing. Okay, so as I told you, we cannot make a diagonal grouping. So likewise we cannot make a odd number of ones. Okay, so for example there are 1 1 1. Okay, there are 1 1 1. I shouldn't group these 3 ones because it is 3 odd number of ones. We have to make a group only with an even number of ones. Okay, so next one is, so in this case, if I am having the values like this 1 and 1 here, the remaining terms are 0. Assume the remaining terms are 0. How do we group this? So we can group these two bits like this. Okay, because the 0 0 and 1 0, that is leftmost column and rightmost column. Okay, so both are considered as a adjacent one because they differ by only one bit. Here it is 0 0, here it is 1 0. Only one bit is changed means it is a adjacent column. So we can group like this also. So next we are going to group 4 bits and 8 bits. So if there are ones like this 1 1 1 1, so we can group the bits like this, that is adjacent 4 ones together as a quarts. It is called as what? Quarts. Okay, so what's its value here? So for these two rows the common terms are, here it is only one common term, a bar, correct? Here it is b bar, here it is b. So we can consider only the common term. Here it is a bar. What about these two columns? Here c bar, here it is c, d and d. So we can take d alone. This is the answer for this grouping. Okay, so and likewise we can group the ones as squares in vertical order or in the horizontal order. Okay, this can also be allowed. There is only one in this place. What will happen? There is only one in this place. We can connect this one with this next adjacent cell. So here overlapping. So overlapping is allowed. This is the overlapping method. Okay, so overlapping is allowed in KMap method. So whenever we are going to solve the problems, you can understand it in a better way. Okay, so next one is 8 bits. So 8 bits means here you can say 1 1 1 1 1 1 1. So we can group these 8 bits in a horizontal order or in a vertical order. Okay, so this is how we can make a octets. So next, let me tell you one thing. There are ones. Okay, so consider there is no other values. There is only one like this. How do we group this? So ignore this value. So there are ones in all the corners. Okay, so how do we group this means we can group all together like this. So here we can group all together like this because here it is 0 0, here it is 1 0, only one bit is changed. Likewise here it is 0 0, here it is 1 0, only one bit is changed. Correct. So these 4 bits can be grouped as a single quarts. Okay, so for that the expression is, for this 2 row the common term is what? B bar. So we can take B bar. For these 2 columns common term is, here it is C bar, here it is C. So it is C is not coming here. Here it is D bar, here it is D bar. So the answer is D bar. So this is the expression for these 4 ones. In KMap, each group of ones represents a product term, and summation of all the product terms gives us a Boolean expression. So we can say each product term is an implicant of the Boolean expression. Hence it is called as implicant. Prime implicants. It is the largest possible group of ones. Okay, so prime implicants means it represents the largest possible group of ones in a K-map. There is one more implicant, that is what? Essential prime implicant. It is a prime implicant which is having at least a single one which cannot be combined in any other way. That is, there is only one possible way of grouping. So, for example, in this K-map, the values are given like this. Okay, so we are going to form a group of ones here. So, we can make a group of 4 ones like this. This is one group. Then here 2 ones are there. So, these 2 ones can be combined along with this 2. Correct? So, this is the group of another 4 ones. And then this one along with this one. Okay, so this is also possible. There are 3 implicants. There are 3 implicants like this one. This is one implicant and then this group of 4. Okay, this is the next implicant and this is the third implicant. Okay, so here there are 3 implicants. Of these 3 implicants, there are 2 prime implicants. That is the grouping of large number of ones. There are 4 ones here. There are 4 ones in this group also, right? So there are 2 prime implicants. And what about the essential prime implicants? So in this group, here in this group, there is a possibility of making a group of ones like this. This 2, this 2, this 2 and this 2 like that. Likewise here also we can make a group with this and along with this column, right? So here for this group there is only one. This one cannot be combined with any other groups except this one. This one is having the combination of these 2 alone. Okay, it cannot be combined with any other groups. So here it is called as essential prime implicant. Limitations of K-map. So here K-map is a convenient method only up to 4 or 5 variables, because as we know that it is a map method where we are having cells. The cell is based on the number of variables 2 power n. If n is equal to 7, so n is equal to 7 means 2 power 7 is equal to what? 128. So we need to have 128 cells. So if the number of variables increases, it becomes more difficult to simplify the expressions due to the excessive number of cells. That is, it is difficult to plot and group the best selection of pairs of 1. Okay, so that's why we are moving on to some other methods if the number of variable increases. Okay.